start Oscail, and when Oscail starts, open the ShelxT folder. In the ShelxT folder, there's a subfolder mg_61. In this folder we'll find the mg61 job, and if we select that job and press open, we're now focused on that job. Now in the folder there are 3 files: the INS file that we've just opened, the data file, and the file written by the Defractometer. Now the first thing we'll do is to run ShelxT to solve the structure. And when ShelxT runs, we'll see it satisfactorily concludes, and if we look at the result, we can see the best result is in P21 on C. We can accept this is a good solution, and if we look at it in Ortex, we can see the atoms, and if we label the atoms, we can see there are 2 nitrogens, 2 bromines, and the rest carbons. This is correct. All atoms have been identified correctly. The first thing we want to do is to renumber the atoms. In edit mode, select the first carbon atom. Press C on the keyboard to change the name. Type in C1 and OK. Click the next carbon atom, press N on the keyboard, and you're prompted with C2. If you press N each time, the number is incremented in a sequence. So we're going through all the carbon atoms from 1 to N. Each time you select the atom, press N to increment the number, and OK. Now we're finished. We select the first nitrogen, press C on the keyboard to start a new sequence, type in N1, select the second nitrogen, press N, N2. We select the bromine. When you select the bromine, it's the same as the others. You press C on the keyboard, type in BR1, the case does not matter. It's fixed by the program. Press N after selecting the second bromine. We have now selected and renumbered all the atoms. Right mouse click ShelxL to refine the structure. The structure is now refined, it hasn't changed very much. The next thing we want to do is add to the INS file the command anis to make the atoms anisotropic, and run ShelxL. ShelxL runs, the atoms are now anisotropic. The next thing we want to do is to start adding hydrogens. Hfix, the default type, is 4,3 aromatic type, and we select the 2 aromatic carbons. Press H when you select an atom to add the hydrogen. Right mouse click, run ShelxL. Those 2 hydrogens have now been added. Now there are 4 more carbons that need hydrogens. Each of them requires 2 hydrogen atoms. So this time we need to select the hydrogen type 2,3 and select the first carbon, press H to add the hydrogens, and when that's finished, right mouse click and ShelxL, and this will add the hydrogens. Now you can see all the hydrogens have been added. Now we need to add the command acta, which will output a CIF file from ShelxL. And the final thing we need to do is to look at the difference map. The peaks are all less than 1 electron per cubic angstrom high, which is satisfactory, and by pressing OK here we move the weighting scheme up and employ the latest weighting scheme. Running ShelxL now gives the final refined structure. Now we would like to get thermal ellipsoid plot, and you can do this by selecting thermal ellipsoids in atom mode. If you press atom centered labels, you'll see that the label size is perhaps a bit small. We can increase or decrease the label size by pressing T plus and T minus on the menu bar, and if we press T plus once, the labels will increase in size, If we look at what size they are now, we can see they're satisfactory. So clear the labels and use the POSL function to position labels. The atom is highlighted, left mouse click selects a position for the label, right mouse click saves it. So left mouse click, right mouse click, and it moves to the next atom. And you continue this, labeling all the atoms. The default is not to label the hydrogens, but you can label the hydrogens if you want. Top right is usually the preferred position, but sometimes a better option is to pick a different position. But we've labeled all the atoms now. Press terminal ellipsoid to get the picture. Press the printer icon to get hard copy. The default name is OK. Select whatever resolution you want and press OK, and the PNG file is written. Now the next thing we want to do is to add the information written by the diffractometer to the SIF file. Use the SIF tab option to do this, and you can add the crystal size and the crystal color here. We need to find the file written by the diffractometer. There it is, and click OK. The information is written. The FOFC plot is quite good, and you get a PNG plot of this. That comment doesn't matter. Now cell check CSD is now run, and various other checks are performed on the system, and you can see it's found our structure on the database. That's because we've already published this structure, and it has 11 carbon atoms as we found in the structure. 2 nitrogens, 2 bromines. Now the next thing we want to do is to get a CheckSIF file. You do this by going to the IUCR website, IUCR CheckSIF, select the SIF file, and we will be selecting level A and B alerts. Open the SIF file, level A and B alerts selected, and send the SIF file for checking. If we scroll down, we can see that there are just 2 C alerts, and these are OK. This structure is fully refined and can be published as indeed it was.